Species-specific defense reactions. In the second part of an experiment by Bowles and Riley, they reversed the contingency between shock and freezing, so now shock punished freezing. Freezing decreased abruptly, but it never went to zero. When freezing was rewarded, it was at 100%. Freezing is a respondent caused by its surroundings and controlled by its antecedents. Rats will also associate the shock with the box, so they automatically froze in that box, but when put in a different box, they did not freeze. This is Pavlovian learning. There are two main points to this. One is that the animal's biology/evolutionary history matters, and the second is that there is a lot of Pavlovian learning and avoidance learning. According to later forms of the SSDR theory, rats learn through Pavlovian learning that one place is dangerous, a fear exciter, and another place is safe, a fear inhibitor. Fanslow discovered that CS is associated with a shock elicit endorphins. These are natural substances released in the brain that kill pain. This analgesia will suppress recuperative behaviors, which are behaviors elicited by tissue damage that promote healing. For example, licking a wound is one of these behaviors, but if they do it in the presence of a predator, it is contradictory towards survival because they need to run away. The predator will also evoke an endorphin response, and fear will inhibit pain, which is an emotional state evoked by tissue damage. Recuperative behaviors also evoke they are evoked in a post-strike phase. The intellectual legacy of the SSDR theory of avoidance learning, including fear, anxiety, and defense after trauma. There are cognitive factors in avoidance learning. Pavlovian cues associated with pain/emotional trauma in humans will evoke behaviors that have evolved as natural defense responses, and this explains anxiety disorders. Organisms learn about danger and safety cues. The CS is a danger cue, but the response it evokes depends on the other support stimuli. Modern avoidance theory involves an organism performing natural defense behaviors and learning about cues in its environment. Organisms can learn SSDRs that are not natural. For example, you can teach a rat to press a lever so as to stop the shock. It takes more training and relies on feedback. Bowles and Grossen experiments show that in situations where warning signal termination is important, leaving the signal on and adding a brief cue at the moment the response was made was equally as effective as improving learning. The feedback cue may have become a conditioned fear inhibitor. When animals are first given Pavlovian training that establishes a feedback stimulus as an inhibitor, it increases the strength of an avoidance response. The avoidance response becomes a conditioned inhibitor. Anxiety disorders often acquire certain safety behaviors because their presence will maintain a fear of the warning signal. The CS will protect the CS from extinction. Seligman and Johnston proved that avoidance behavior can be very persistent, but there are problems with their theory. Response learning seems to follow the rules of Pavlovian learning. Learned helplessness. Seligman found that avoidance learning was slow if subjects are first given an inescapable shock before avoidance training. Dogs showed a motivational deficit, which is no initiated responding when they were able to escape in the second phase. Also, they had a cognitive deficit. This is when they failed to show learning in the second phase. Dogs exposed to escapable shock first were protected from these deficits, called the immunization effect. The learned helplessness hypothesis is believe that one's actions and termination of the bad stimuli are independent of each other. The phenomenon itself is called the learned helplessness effect. Learned irrelevance is when there is zero contingency between a CS and a US, so it is harder to associate the two events when they are later paired. Because of this, generalized learned irrelevance can develop. Helplessness and depression develop mainly when uncontrollability is associated to the person's own failures and is persistent. Learning optimism is the key to kill depression. Several factors can contribute to the escape deficit. First is that exposure to an inescapable shock can make an animal less active. The second is that the inescapable shock numbs the animal's pain. The third is that exposure can reduce the brain level of certain neurotransmitters such as serotonin and norepinephrine. And the last one is that controllability of a bad event has a powerful influence on the stress it produces. This can cause rats to develop ulcers and influence psychological impact. Cessation cues, which are cues that are right before shock termination, have an immunization effect, which is exposure to the inescapable shocks with an added cessation cue protects the subjects from helplessness caused by future inescapable shocks.